All right, last goal on this section is to analyze the pieces of the quadratic formula. I sort of started it for you here, but hopefully you can fill it out on your own. If you need to, you can always sing the little song to yourself, negative b plus or minus the square root of b squared minus 4ac all over 2a. So there's two components that exist here in the quadratic formula. Those components are this part right here, and then this part right here. Well, what are those? Well, the green part is negative b over 2a, which is the axis of symmetry. Can spell right. And then the red part is the discriminant. Okay. So what are they? Well, the axis of symmetry, if I have some quadratic like this, and you can look back to the graphic organizer on the very first page of the PDF that I sent you, but if I have this line that breaks everything up into a symmetrical distance away from it, it would be the axis of symmetry. And what's great about the axis of symmetry is that it has an equation of x equals negative b over 2a. Okay. And that what's nice about that is that because it passes directly through the line of symmetry here, it's the perfect mirror point, you know that the vertex is on that line. So if I want to know a quick way to determine my vertex, I can say that my vertex is just going to be negative b over 2a, and the y value of the vertex will just be the output, f of b, negative b over 2a. So that's a nice way to do a shortcut to find what your vertex is, but it's not necessarily the only way. The discriminant is the square root part, b squared minus 4ac, and really it's just the numbers. It's not necessarily, we don't need to worry about this. What the discriminant tells us is that if it's positive, we're looking at two roots that are distinct. If it's 0, we're looking at a double root. So, for example, if I got 0, my root might be looking more like this, where your vertex is your root. This one would look more like this. And then if it's negative, what we're looking at, which we've talked about in the past, is two roots, but they're both imaginary. So two imaginary roots. So you must have either a positive quadratic that's floating above the axis or a negative quadratic that's floating below the x-axis. Okay. We looked at those problems a while back where we had to analyze what the value of k might be in a certain function in order to make sure that it's always positive or prove that you're always getting two roots, something like that. So this is a good way, this can be a good way to quickly analyze how many roots and what type we might be looking at for a function. Okay. The discriminant also, or this formula itself, the whole thing, can be looked at like this. So imagine I have some quadratic and I have the axis of symmetry running through it. So I have some x equals negative b over 2a value. And then when I look back at the quadratic formula up here, I have a plus or minus some value. So I have an add the root b squared minus 4ac over 2a, and then I have the minus b squared minus 4ac over 2a. And those values add to the axis of symmetry to give us our root that's above it and our root that's below it. So that can be a nice way to talk about the distance from the axis of symmetry can be seen here by adding or subtracting this value. The last thing I gave you in your notes is just kind of a little cheat sheet. You can use it if you want to. But I did notice on the SAT or the PSAT practice, there were quite a few questions that said solve some equation, and those equations were quadratics. And so remember, there's lots of different ways to solve a quadratic. The one we use the most is the quadratic formula because it works for all situations. It's kind of a catch-all, so it's nice to jump there. But if you quickly see that an equation is factorable, you should just break it down and solve for your x's. Or if you have a term, an equation that's like this, x squared plus 4 equals 0, you can just shift your term over to the other side and square root. That only works when you don't have a linear term. And then here's factorizing, completing the square, which works but is not super friendly for solving quadratics. Quadratic formula, and then visually we can always see the solutions of a quadratic formula by looking for your roots, zeros, x-intercepts. It doesn't matter what you call it, they're all the same thing. So just a little tip for future solving of quadratics.